Pre-AP Calculus, Notes 9.1. This is video 6 of 7, reviewing law of sines. Let triangle ABC be any triangle with sides A, B, and C representing measures of sides, opposite angles A, B, and C respectively. There's a picture that shows that. The following equations hold true. A squared equals B squared plus C squared minus 2BC times cosine of angle A. So important things here to remember. Whatever side you start with is the angle you're using. Something else that could be helpful in memorizing this first part is essentially the Pythagorean theorem. Now the letters look a little bit different, but like in this version, the letters are the same. So as far as memorizing goes, the side you start out with is the angle that you use. You never use those letters again. You square each of the other letters added together, then you subtract 2 times the product of those same two sides times cosine of your angle. This is a law of cosines, so it uses cosine. These other two versions of the equation are just the same, well, we're using different angles. This is angle B and C, so we start with side B and we start with side C. When can you use the law of cosines? Well, there's two cases. You can use law of cosines if you want to find the third side of any triangle if the measures of two sides in the included angle were given. So if you're given an angle and if you're given two sides in the angle between them, you can use law of cosines. Or if you're given the lengths of three sides and you want to find an angle, you can use law of cosines. It's important to know that if you can avoid using the law of sines to find the largest angle, you should avoid it. And there's some complications that go along with that. It's called the ambiguous case of sines, and I don't think we're going to get into that this year. Long story short, when can you use law of cosines? When you can't use law of sines. Remember, a law of sines can be used anytime you have an angle and the side opposite that angle. If you don't have that, you can use law of cosines. Let's look at an example. George fenced a triangular area for Danny DeVito, his miniature pet donkey. Let's draw a triangular area. Two sides of the area are 400 ears of corn long. This is an isosceles triangle again, which tells us these base angles have to be the same. And they meet at an angle of 46.3 degrees. If the fence is to be built around the area, how many ears of corn will he need for fencing? We need the perimeter for this again. We'll call this angle C, side C, angle A, side A, angle B, side B. We're going to use law of cosines for this because we don't have an angle and side opposite that angle. We could do some algebra and we could figure out these angles, but let's just say that we don't. So which law of cosines equation are we going to use? We're going to use whichever one uses the angle that we're given or the angle we're trying to find. We have angle C. So every time you use the law of cosines, write it out with letters first before you put numbers in. So we got side C squared equals A squared plus B squared minus 2AB times cosine of the measure of angle C. Fill in the numbers that we know. We don't know side C. We know A is 400. We know B is 400. We know that it's 2 times 400 times 400, and it's cosine of angle 46.3 degrees. We cannot simplify this without rounding. So simplify everything else that you can. 400 squared is 160,000. So is, by the way, this was supposed to be squared right here. I left off the squared. It's another 160,000. 400 times 400 is 160,000. And I'm sorry, was it 6? Oh, I'm sorry. I misread this. Please forgive me. 400 and 600. Doesn't say, I just skimmed it and said two sides are 400. That's not what it says, 400 and 600. So let me fix my mistakes in red. $600 squared is 3,600. 2 times 400 times 600 is 480,000. I'm really sorry. I'm sure you were super confused. As well you should have been. I have a skimming disease. Now we combine like terms. It's important to note this is all one term right here. Terms are separated by addition and subtraction. So these are like terms. This is all one term that's not like those because this has got a cosine of 46.3 in it. So c squared is going to be 520,000 minus 480,000 times cosine of 46.3 degrees. This is as simple as we can make the right side without rounding. To get c by itself, we're going to square root both sides. We're looking for a positive answer because we are measuring out years of corn. Put this in your calculator, you're going to get the positive version of this, which I did not round appropriately once again. So let me see if I can write this in here well. So we got 520,000 minus 480,000 times cosine of 46.3, and I'm square rooting that monster. I think I typed something in here wrong. Hold on a second. Because I got 434 point something. I'm missing a zero here. Oh, geez, don't want that. There we go. So we get 434.023. Doesn't answer the question. Question says, how many ears of corn does he need? Well, the ears that he needs is the 400 he starts with and the 600 that he starts with, and then the unknown side, which is 434.023. Probably be fine to round that to the nearest ear of corn. George needs 1,434.023. That's what that sums to. Ears of corn. All right, that concludes the review of law of cosines. We got one more video for this section, and it is just a random triangle, and we're going to end up seeing if we need to use law of sines or cosines to complete the problem.